Let's see, where are we at on this thing? We still in chapter 7?
Yeah.
Which one?
0.2.1.
Did we do any of these?
No.
Let me read these first before I think we did do this one.
No, because I just learned this today.
Really? Okay. Alright. Let's talk about what the curve of y equals sine x looks like. That's one period of it. And there's some key points on this curve. Are you in radians yet, or are you still in degrees?
Radians.
So that's pi over 2. That's pi. That's 3 pi over 2. And that's 2 pi. So the period of a sine curve is 2 pi. Now, if I wanted to shift this up by 1 unit, what would happen? What would go ahead?
It would start on 1.
Okay, so actually the entire curve would just vertically shift up by 1 unit without changing its shape. And in fact, the first thing I would probably do would be to draw a new horizontal line of symmetry, because the horizontal line of symmetry of my black curve is y equals 0. So the new horizontal line of symmetry is y equal 1. And I'm going to draw my new curve just exactly like my old one. Only everything's up by 1. It touches that x-axis right there. So that's what it looks like. What do you have to change in the equation to move the graph up 1 unit? In other words, it's no longer y equals sine x. What is it?
It's y equals sine x plus 1.
With the plus 1 being outside the function. In other words, it's not y equals sine of x plus 1. That's different. That's a horizontal shift if it's inside the parentheses. So if I'm looking for a vertical shift, then it's outside the function. What are the intercepts of the new equation?
3 pi over 2.
Comma 0, okay. In other words, that point right there is 3 pi over 2 comma 0. Label them with their coordinates. When you listed intercepts, did you list more than one?
Not usually.
No, we didn't. We only listed one. Should you have? Well, it kind of depends on whether they're talking how many periods of sine curve we're looking at. In other words, I only drew one period of this thing. If I continued and drew another period, then there would be another x-intercept right there. There would be an x-intercept every 2 pi. And there would also be one right there. So I'm not quite sure if that's what they're getting at here. In other words, for one period only, there would only be one x-intercept on my red curve. But if I consider the domain going all real numbers from negative infinity to positive infinity, well then there's multiple x-intercepts. And they occur every 2 pi, starting at 3 pi over 2. So like I said, I'm not exactly positive what they want with this. Now, in this one, they specifically say that we're only looking at one cycle of sine x. Notice that that's not the way you draw a sine curve, right?
Yeah.
Well, by that I mean, if I'm drawing a normal sine curve, well, it starts at 0, goes up to its maximum, comes back down, goes down to its minimum, comes back up, like that. So what's the difference between these two curves? The one that they had drawn on there and the one that I drew. This one is actually y equals sine x. The one they drew is some horizontal shift. It's y equals sine of x plus or minus what?
Pi.
Yeah, and it's plus pi. In other words, my black curve is shifted to the left by pi units. In other words, the new curve starts there instead of there. So it's a pi to the left, and that comes out with x plus pi. I suppose you could also say that it's shifted to the right. In other words, the new curve looks like that, so it's also, I could write it like this, x minus pi. Either one of these y functions describes that curve. In other words, we do not have to draw all periods of a curve for all the periods to be there. They only drew one period of this curve, but if I finish drawing this curve, it looks like this. Okay, well you could say that the sine curve starts right there, which means it would have been shifted pi to the right. So with the sine function, pi to the right or pi to the left is the same curve. It specifies these two curves right here are the same, exactly the same. One would be on top of the other. So in answering how many units to the left it was shifted, that would be pi. Nah, I don't even know what it wants with b, but we've covered it. In other words, by considering also a shift to the right, we saw that they were the same thing. I remember this question, Nicholas. I mean, we can go over it again, but that's okay. I'm not doing this with any, I don't have this CPM stuff with any other students, so I know it had to be you that we went over it with. So which of those three things is best modeled by a sinusoid function?
B and C.
Yeah, because A is modeled more like, sorry, thought I was writing on it. A is modeled more like this, steadily increasing every year. Most schools would be like that. Hunger level, you wake up in the morning and it's pretty high. After you eat, it drops low. Then it goes up high and then drops low, goes up high. Well, that's a sinusoid function. It's not around the x-axis. The x-axis is not its horizontal line of symmetry, but it's still a sinusoid function. It's been shifted up by some amount. And the high tide level point along the coast, this is perhaps the most famous sinusoid model, because tides do that. That's high tide, that's low tide. And low tide doesn't go all the way down to zero either, like I've drawn it. It would be maybe more like this, where that's high tide, that's low tide. And it can be measured. So all you have to do is go out and measure the high tide and measure the low tide, and guess what? You can almost write the sinusoid function. You need a little bit more information, but not a lot. We know the period of the tides is, I think it's 1 day, maybe it's only 12 hours. I don't know, I'd have to do a little research on that. But yeah, this one puzzled me last time we did it, and I'm not in any better understanding of it this time. Remember, I wasn't quite sure how to draw it. It's a circular track. So that's a circular track if looked at from above, with the center of the circle being 50 feet underground. So if I look at it from the side, I've got the center of the circle being something like that. Passengers board at the highest point. They begin a blood-curdling drop. Write a function that relates the angle traveled from the starting point to the height of the rider above or below the ground. Well, I don't think that's the correct picture. I think it's like a Ferris wheel. Am I wrong?
I think so.
That's the only thing that makes sense. Okay, let's draw it like a Ferris wheel. Because a Ferris wheel is actually a great problem for talking about sinusoid functions. Now, the dotted line that I've drawn there is the ground. Okay? It's a circular track with a radius of 100 feet. And the center of the circle will be 50 feet underground. Well, I didn't draw it right once again. Let's draw it again. The center, let's see, if the center of the circle is 50 feet underground, and the radius is 100 feet, then the circle looks something like that, where this distance is 50 and that distance is 100. You with me?
Yeah.
I think this must be what they're talking about.
Okay.
Write a function that relates the angle traveled from the starting point to the height of the rider above or below the ground. Well, it'll tell us where you get on. I guess we could figure that out. You get on right there, let's say. And that, redraw my picture a little bit. That's 100 feet radius. And if that's 50 feet, that's a 1, 2, square root of 3. A 1, 2, square root of 3, which means that's 85 feet, right there. It's not the radius of the circle. It's the side of that triangle. And this is 50 here. In other words, all I did was use the Pythagorean theorem to solve for that side. And I approximated it. It's approximately 85. So I believe here's what they're asking. Passengers will board at the highest point. Alright. Help, I guess, if I read the problem. This might not even be the problem that they're talking about, but we're going to assume passengers board right there. And let's erase that. Although we do know that that's 50 feet. That's 50 feet there also. What function relates the angle traveled to the height of the rider above or below the ground? Well, let's say the height as a function of theta is equal to, well, what function starts from a high point and goes down to its low point, which is what's going to happen to this rider. It's going to start, okay, cosine, and this is a terribly difficult problem, given that the problems prior to this weren't hard and didn't involve anything like this. Makes me wonder if I'm interpreting it correctly still, especially since they're asking that relates to the angle traveled from the starting point to the height of the rider above or below the ground. So let's say after a minute or two, the rider is right there. And the angle that they're talking about, I believe that angle right there. They want to know the equation of this sinusoid function that tells us, the problem is they don't, okay, I get it now. They don't tell us how fast the ride goes around one time. They want us to relate it to that angle. All right? The height of the rider at the beginning is 50 feet above the ground, correct?
Yeah.
Well, if I draw a triangle right there, the height of the rider is now 50 minus that length, correct?
Yeah.
That y. Well, this is 100. Oh no, that's not 100. That is, let's see. Ooh. I got my theta drawn wrong. I gotta draw this like this. Let's go back just a second. In other words, when the rider gets to there, hold on. It relates the angle traveled from the starting point to the height of the rider above or below ground. So I think that this is theta right here. And now I've got a triangle I can solve, because I know the hypotenuse of that triangle is the radius. It's 100. And the height. Okay. How about if I do the cosine of theta? That is going to be 50 plus y over 100. If I look at this triangle right there, and I look at the cosine of theta, remember that side's 50. This is what I'm calling y, which is the height that the rider is above the ground. And I can certainly say that the cosine of theta equals the adjacent side over the hypotenuse. Well, the adjacent side is 50 plus y over 100. So that is the answer. Write a function that relates the angle traveled, that be theta, from the starting point to the height of the rider above or below the ground. Well, that's y. So here's the equation they're looking for. Cosine of theta equals 50 plus y over 100. Wasn't so hard afterwards. Just was hard figuring out what the heck they were talking about with their ride. What's the answer on this? First of all, let me draw. This time I'm going to draw more than one period. Here's one period of the sine curve. Here's one more. Okay? And then in red, I'm going to draw more than one period of the cosine curve. Here's one period. There's another. What is the relationship of one of these graphs to the other? What they're going for here, I'm not sure that they've asked it quite in a proper way, but either one could be the parent of the other with a horizontal shift. Correct?
Yeah.
In other words, this cosine curve is the sine curve from there to there. That's one period of cosine, which means that if I took my sine curve and moved it pi over 2 to the left, I would have a cosine curve. So the only difference, it's proper for me to say that the sine of x would be equal to the cosine of x plus pi over 2, which means, no, excuse me, I got it backwards here. I got the cosine curve is equal to the sine curve adjusted by pi over 2 to the left, which is what that says. So you got cosine x equals sine of x plus pi over 2. That's always a true statement. And therefore, because one can be the parent of the other one, and you could go either way. In other words, I could say cosine is the parent of sine, or sine is the parent of cosine. All right. These are not as hard as they look. The way you take a graph and you turn it into a function is you solve for A, B, C, and D. Okay, so let's just work with this one on the left here. A, the amplitude, what's that equal to?
The vertical or the asymptote.
The way you get amplitude, in other words, here's the function that we're trying to put it into. A sine of B x minus C plus D. In other words, we should be able to take anything that we're looking at here and put it into this. The only thing we got to do is solve for A, B, C, and D. Well, A and D are easy to solve for. A is the maximum minus the minimum divided by 2. What's that? There's your maximum, 3. There's your minimum, 1. What's 3 minus 1 divided by 2?
1.
So that's A. D is the next easiest thing. D is the maximum plus the minimum divided by 2.
And 2.
And notice that is where the new horizontal line of symmetry goes, at y equal 2. Okay, so finding A and D are really easy. You just have to keep straight. A is the difference of the two, D is the sum of the two, and both are divided by 2. Now, the way we go here is really kind of from right to left. The next thing we really want to do is figure out the period. Okay? Well, the period, you can measure it from peak to peak, or trough to trough, or starting point to next starting point. The key is you're looking for one period of that sine curve. Well, that's one period of it. It's not the way a normal period of a sine curve will look, but that doesn't matter. We just want the distance between these. How far is it between those two hash marks?
I can't really tell.
It's 2 pi. In other words, there's 2 pi, there's 0, that's minus pi over 4. That's actually 7 pi over 4 right there. So the period is 2 pi. Okay? Now, B is related to the period in a very specific way. B equals 2 pi divided by the period. So what's my B equal to here?
1.
We only have one last thing to solve for and we'll have our function. And that's the phase shift. Now, this is a little more complicated. A, D, and B are really easy to figure out. The phase shift kind of depends on which function you're going to use. And I got 4 choices. I can use sine, I can use minus sine, I can use cosine, or I can use minus cosine. And the one that I'm going to use is the one that has the least phase shift. Alright, well, in red, I'm going to do the top one, sine. That sine would start right there, and it would go to there. And that phase shift would be that amount. You understand why?
Yeah.
Okay. If I look at the negative sine curve, well, the negative sine curve starts over here. Well, that's 3 times that amount. So I'm not using the negative sine curve to determine my phase shift. Let's look at cosine. Cosine starts right there and then goes like that. Well, that's 3 of those units. So I'm not using cosine curve either. In other words, I'm going to choose the one that's closest to the y-axis. Okay? Well, negative cosine curve almost works. If I look at the negative cosine curve starts at its minimum and goes up to its maximum and then comes back down to its minimum. So I got 2 choices now. I can use a negative cosine curve or I can use a positive sine curve. They both are going to have the same phase shift, which is pi over 4. In one case, it would be a phase shift to the left. In the other case, it would be a phase shift to the right. Well, let's use this red one right there, the one that starts there and goes up. There's my sine curve I'm going to use. I can see that it's pi over 4 to the right. Now I got everything I need. Okay, so y equals 1. Don't need to write it, but I will just for clarification. Times the sine of b is also 1. Times x. The phase shift is to the right, which makes it minus pi over 4. And d is 2, plus 2. So there's my equation. And if I remove all of the 1's, I've got a really nice simple sine of x minus pi over 4 plus 2. There's the answer. That's the prettiest. I could also do a minus cosine in place of sine, and then it would be plus pi over 4 because the phase shift would be in the other direction. But either of those is equal. Now, let's have you try to do B. Tell me what A is.
The maximum minus the minimum divided by 2.
Okay, which is what in this case? What's the maximum minus the minimum divided by 2?
2 plus 1 divided by 2, which is 1.5.
So A is 1.5. The next thing that's easiest is D. What's D?
3 minus 1 divided by 2, which is 1.
2 plus minus 1, which gives
Oh, yeah.
1 divided by 2, so D is 0.5. And notice that is what D is. In other words, D is always this horizontal line of symmetry. That's the line that this curve is symmetrical up and down about. And that's always, you get that by D. Okay, you don't always have to draw it in there, but okay, now let's figure out B. You can't figure out B until you figure out the period. Because remember, the period B is equal to 2 pi divided by the period. So I got to figure out the period. What's the period? And the only real 2 points I have on there is that trough and that trough. What's the difference between those 2 points?
2 pi.
So B again is 1. Now C. What curve can I use so that there's no phase shift at all?
0.
Which curve starts there?
Oh, cosine.
Cosine, exactly. So C is 0 if I use a cosine curve. So my function has to be 1.5 times cosine, not sine. B is 1. No phase shift, but I do have a vertical shift, up 0.5. So there's my function. And that's much better than using a sine. Notice that if I used a sine, I would have a phase shift of pi over 2. I would have to start the sine curve there so that I go up and then down. You get the phase shift concept?
Yeah.
Let's do this bottom one here. Hold on. Well, yeah, I guess we can do it one at a time. So, A,
1,
D,
2,
B,
1, or 2 pi.
Well, if we figure out what the period is, in other words, we can't solve for B until I solve for the period. Well, there's a nice point to take, and there's its equivalent point. So if I read this thing carefully, it looks to me like that's exactly 2 pi between those 2 points, which makes B 1. Now, C, this is the tricky one. Remember what our choices are. Sine, negative sine, cosine, or negative cosine. And we're going to use whichever one has the least separation from the y-axis. So let's start with the sine. The sine, if I draw that in red, well, I would have to start there, right?
Yeah.
If I want to use a negative sign, which I will label in green, it would actually start right there, right? Do you see why that's the beginning of a negative sine curve? In other words, the negative sine curve would start in the middle, go down first instead of going up first. Okay, so far that's the best choice. Let's look at cosine curve. If we make the cosine curve, we start right there. Well, that's 2 grid marks over. That's not as good as the green. And if I make a negative cosine curve, I got to start there, which is like 4 or 5 grid marks over. So the green, or the thing I've circled there, is the closest to the y-axis. So I'm going to use a negative sine curve. So my function is going to be what?
Y equals negative sine.
That's pi over 6 is that phase shift. In other words, that is 1/3 of the distance to pi over 2. So that's got to be pi over 6. So it's negative sine of what?
X minus pi over 6.
Good. What's the rest
Plus
of it?
2.
Perfect. Now, I don't know if they go through these with you in class like I've done or not, where they give you those 4 options. In other words, usually in class you got to choose between sine or cosine. But clearly in this case here, a negative sine was the better choice because it gave us the smallest amount of phase shift. If I would have used either the positive sine or positive cosine or negative cosine, I would have had a bigger phase shift than pi over 2. So if I'm going to make my rule be use whatever is the least phase shift, then you have to consider all 4 of these. I said I don't know if they do that in your class or not. I'm just going to assume that they do. If they don't, they should. What's A?
3.
What's D?
Negative 1.
What is the period? Which is the next question to really ask. And all I have to do is find the distance between that point and that point.
2 pi.
Okay, so B is again, so the period is 2 pi. They're making this easy for us. B is equal to 1. And finally C. So best, just looking at it, what do you think the best function to use would be?
Negative cosine.
You're all over this. Right there. That has another phase shift of pi over 6. So the phase shift is pi over 6. Is it plus or minus? Phase shift.
Minus.
Which makes my function be?
3
Negative
cosine.
Negative 3. In other words, amplitude is 3, but that's just an absolute value. If I'm using the negative cosine, I'm going to put the negative sign in front of the 3.
Okay.
And then not put it there. What's the rest of it?
X minus pi over 6. Minus 1.
Good. Very good. All right. 7/130. Can't say I'm terribly fond of the way they want a verbal explanation of these things. What they mean is that if you graph the cosine of theta, it looks like this. If you graph the cosine of theta plus 360 degrees, which is a shift of 360 degrees to the left, it looks like this. And if I graph more of it, it just keeps going. So I don't see any difference between the two graphs. Why not? The answer is that one graph is a phase shift of 360 degrees left of the other graph, which puts it the same graph. I'm not sure what else they want for an explanation, but that would be mine. Okay. 2x squared minus 4x plus 5. 2x squared minus 4x plus 5. Well, they said they want us to complete the square to put it into vertex format. Okay? In other words, well, they didn't actually say that. Complete the square to change the equation into graphing form. Well, graphing form is vertex format. That's what they mean. And vertex format for a parabola, do you remember what it is?
Y equals x or a times x minus h squared plus k.
Good. So we got to make this thing look like that. Well, right now it doesn't look anything like that. And the way I'm going to do it is I'm going to complete the square. Here's what you do to complete the square. You separate the two items that have an x in them and set the number off to the side for the moment. So far I haven't changed anything. Now, before I can complete the square, always, no matter what I'm completing the square for whatever reason, I've got to make sure that the coefficient is 1, not this number that's in front of my x squared term. It's currently 2. That means I got to factor out that 2, whether it factors nicely or not. In other words, this one happens to factor nicely, but turn that into a 3x and I would still factor it out. The key on these problems, make sure you do not change it from line to line. In other words, I've still got the exact same function, right? Between my first line and my last?
Mm-hmm.
Okay. Now we're ready to complete the square. How do I complete the square? Inside the parentheses.
Yeah, you factor it.
Well, you take half of that coefficient. You don't factor it. This is a very special technique. What I do is I take half of the coefficient of the x term and I square it. And I add it right there. Now, when I wrote that number in right there, how much did I add to the right side of this equation?
2.
Which means I've got to subtract 2 to balance it out. Now, my bottom row is the same as the row above it. Still have not changed anything. In other words, I could easily get back to this line right above it. The beauty of completing the square is that it now allows me to write what's inside the parentheses in x minus h format. In other words, it's x minus 1. Whatever I got, when I took half of that coefficient, that's what goes there. And then combine the two numbers, and you got 3. Now notice that it's in perfect vertex format, and that's valuable because if I'm trying to graph a parabola, I want to know where the vertex is. That's the first thing I need, is the vertex. Well, where's this vertex?
1,3.
Right there. Does it open up or down?
Up.
And it's been vertically stretched, so it's a little skinnier than a normal parabola would be. But that's the graph of it that I've just graphed there. It would actually go through the y-intercept at 5, so I know what that point is, comes at 5. And I know what that point is. That's 1, 3. So I could actually figure that point pretty easily. And now I have 3 points. That's all I need to graph a parabola. All right. That's completing the square. And this was probably a relatively difficult completing the square problem, mainly because of this 2 that I had to factor out. Most people, when they write +1 in there, they will counterbalance it by subtracting 1. But you always need to be aware that whatever number I write in here is being multiplied by that 2. So if I write in a 1, I'm really adding 2 to the right side of the equation. Let's make sure we answered everything they wanted. We identified the vertex. We sketched the graph. The rest is just talk. Words of encouragement. Well, I think we have just enough time to do this. At least we do A. At some point, what do I have to do on this problem?
Factor out an X.
What's that? Well, first of all, tell me what the y-intercept of that thing is.
Alright, so when X equals 0.
Okay, so what's the y value when x equals 0?
0.
Okay, well, we got the y-intercept easy. Now let's get the x-intercept. Well, to get the x-intercept, I set y equals to 0. And then I got to do some factoring. Well, what's the first thing I can factor?
An X.
Why would they give us one that required us to use the quadratic formula? Hold on. Maybe not. Maybe not. Yeah, maybe. In other words, this is kind of an interesting problem, actually. If this has imaginary solutions, then those do not cross the x-axis. So the only x-intercept would be x equals 0, right?
Yeah.
How can we tell if this has real solutions or imaginary? We know we can't factor it. There's no way I'm getting to 10. But I could analyze the discriminant. If the discriminant was negative, I would know it would have 2 complex solutions, and I'm done with the problem. If the discriminant is positive, then I got to go ahead and solve the quadratic formula to come up with my other two intercepts. Well, the discriminant is b squared minus 4ac. Well, that's 100. That's b squared minus 4 times 2 times minus 1. That's 108. So it's definitely a positive number. Okay? So the only thing left is I got to solve for it. You want to fill in stuff for me? If I'm using the quadratic formula, fill it in. What's minus b?
10
What's the rest of it?
plus or minus the square root of 100 minus 4 times 2 times negative 1 divided by 4. Or, yeah.
Okay, so what we have here is 10 plus or minus the square root of 108 divided by 4. Well, 9 goes into that. 9 goes into that 12 times, which means that 18 goes into that 6 times. No, that doesn't help. Let's see. If we simplify that one step at a time, I get 10 plus or minus. So what I say, 9 goes into it 12 times. So it would be 3 root 12 over 4. But then root 12 is root 4 times root 3. So that brings another 2 out, leaving behind a root 3. So now that's my answer. I can simplify it a little bit. Can divide top and bottom by 2. That's about all I can do. So I get 5 plus or minus 3 root 3 all over 2. There's your other two zeros. And they are both real numbers. In other words, I've got 3 zeros on this thing, as I would expect. When you have a cubic, you generally have 3 zeros. One of them is at x equals 0, and there's the other two, at those two. And the y-intercept was y equals 0. I guess we didn't get to both problems, but we got A. Let's see how many there are. We don't have time to do B right now, but I just want to know whether we're... That was 132? Yeah, okay. We didn't quite finish 722. So we got to go back to 722 next time. All right?
Yeah.
All right. Well, Nicholas, your math skills seem to be improving. You're doing pretty good here lately. Is your grade improving at all?
Yeah.
Well, good. Glad to hear it. It should. You've been putting in a lot of work. So I will talk to you next time.
Okay. Yeah, bye.
Bye-bye.